Life on Earth operates in cycles that we can sometimes predict, such as day and night, or the changing of seasons. These phenomena occur over short periods and are often easily explained by science. However, beyond these familiar cycles, there are exceptional climatic phenomena that have the potential to disrupt the balance of ecosystems, significantly affecting weather patterns, ecosystems, and even the global economy. One such phenomenon is the El Niño Southern Oscillation, ENSO, commonly referred to as El Niño and La Niña. Though they originate in the Pacific Ocean, their impact is felt across the globe. These phenomena not only alter weather patterns but also bring about substantial consequences. Over the past few decades, El Niño and La Niña have caused devastating floods, prolonged droughts, persistent famines, and severe degradation of marine ecosystems. A striking example is the severe El Niño event of 1998, which destroyed 16% of the world's coral reefs and triggered a catastrophic chain of coral bleaching events that continue to this day. ENSO, or the El Niño Southern Oscillation, is a global phenomenon with an average cycle of about 5 years. But don't let that number fool you. In reality, the cycle can vary from 2 to 7 years and brings unpredictable climatic changes. So what exactly are El Niño and La Niña? Why are they considered two sides of the same cycle? And why do they have such a profound influence on the world? If you've ever heard the name El Niño and thought it sounded more like folklore than science, you wouldn't be entirely wrong. The term originated in the 17th century when fishermen along the coasts of Peru and Ecuador noticed that around Christmas, the ocean waters became warmer, making fishing more difficult. They called this phenomenon El Niño de la Navidad, meaning the Christ child. It wasn't until the late 19th and early 20th centuries that scientists realized that this warming of ocean waters was not just a regional event, but part of a global climatic cycle. By the mid-20th century, advancements in meteorological research allowed scientists to confirm that El Niño and La Niña are opposite phases of the same phenomenon, the El Niño Southern Oscillation. Under normal conditions in the Pacific Ocean, trade winds blow strongly from east to west along the equator, pushing warm water toward the western Pacific. In the eastern Pacific, cold water rises from the ocean depths to the surface, creating a nutrient-rich environment that supports diverse marine life. However, during an El Niño event, the trade winds weaken or even reverse, causing warm water to accumulate in the eastern Pacific. This disrupts the natural food chain, from plankton to larger fish, and triggers severe weather changes. Conversely, when La Niña takes over, the trade winds strengthen, pulling more cold water to the surface in the eastern Pacific. This results in a drop in global temperatures and fosters distinct weather phenomena such as storms and flooding. El Niño and La Niña are not merely climatic phenomena. They are powerful disruptors of global ecosystems and economies. They affect agricultural production, food prices, and even energy security. But why do these events occur cyclically? What makes them so difficult to predict? And most importantly, can we mitigate their negative impacts on human life? Let's take a closer look at the Coriolis effect, a fascinating phenomenon caused by Earth's rotation that plays a crucial role in shaping global weather patterns. If Earth didn't rotate, air would flow straightforwardly from the high-pressure poles to the warmer low-pressure equator in a north-south direction. However, due to Earth's rotation, these air currents are deflected as they move, creating a complex climate system. Near the equator, within about 30 degrees latitude north and south, commonly called the horse latitudes, air in the northern hemisphere is deflected southwestward, while in the southern hemisphere, it's deflected northwestward. These airflows, known as trade winds, blow strongly from east to west, pulling warm water from the South American coast toward Asia. At the same time, colder water from the ocean depths rises to the surface to replace it, a phenomenon called upwelling. Upwelling is vital for marine ecosystems, as cold water is often rich in nutrients. It sustains phytoplankton, which feeds fish and larger marine animals. However, when this system is disrupted by El Niño, the cascading effects on ecosystems and weather are profound. During an El Niño year, trade winds weaken or even reverse. Warm water, instead of flowing toward Asia, accumulates in the eastern Pacific near the Americas. This reduces the upwelling of cold, nutrient-rich water, causing severe declines in marine life. Simultaneously, this warm water alters atmospheric circulation, triggering significant global weather disruptions. In North America, El Niño pushes the Pacific jet stream southward, causing warmer, drier conditions in northern US and Canada, while regions like the Gulf Coast and southern states become wetter. In Peru and Ecuador, heavy rainfall often leads to devastating floods. A notable El Niño event in 1997-1998 caused rainfall in Tumbes, a typically arid region, to increase 16 times above average, resulting in catastrophic floods that destroyed bridges, homes, and displaced hundreds of thousands. El Niño's impacts extend far beyond the Americas. In South Asia and Australia, rainfall plummets, leading to severe droughts. India has faced crippling famines, and Australia's prolonged droughts often fuel massive wildfires. With vast grasslands, Australia has endured some of the world's most devastating wildfires. A prime example is the 2020 wildfires, which occurred without an El Niño, but still burned over 50 million acres, leaving a lasting toll. On a global scale, El Niño doesn't just shift weather patterns, but also raises average surface temperatures by approximately 0.1 degrees Celsius. However, not all El Niño events are severe. Some are mild and easily overlooked. The average duration of El Niño is 9 to 12 months, but in some cases it can persist for over a year, with far-reaching consequences. Global climate is an extraordinarily complex system, responding to countless inputs. Thus, no two El Niño years are alike. Complementing El Niño is La Niña, a contrasting yet equally significant climatic phenomenon. If El Niño is akin to a disruption of normal conditions, La Niña amplifies the normal. During La Niña, trade winds don't weaken, they grow stronger, pulling warm water even more forcefully from the South American coast toward Asia. This intensifies the upwelling of cold, nutrient-rich water near South America's coast, benefiting the fishing industry. The increased cold water supports the proliferation of fish species, such as salmon and squid, creating a robust food chain in regions often affected by ecological declines during El Niño. Conversely, in Asia, La Niña brings wetter than normal conditions, increasing the frequency of tropical storms. In North America, the jet stream shifts northward, causing severe droughts in the southwestern US, while the Pacific Northwest experiences heavier rainfall. A striking example is 2022, when La Niña exacerbated the worst drought in 1,200 years in the US Southwest, leaving reservoirs like Lake Mead nearly depleted. So, where are we currently in the ENSO cycle? According to recent reports from the National Oceanic and Atmospheric Administration (NOAA), a year-and-a-half-long La Niña phase has just ended. The Equatorial Southern Oscillation Index, EQSOI, a critical measure of ENSO states, has dropped from 1 to just 0.1, indicating that climate conditions are returning to near-normal levels. However, early signs suggest that El Niño could emerge by the end of this year. NOAA forecasts indicate a 60% probability of El Niño developing by next fall. If this prediction holds, the impacts could be significant, particularly for countries like India, which has already issued warnings about the potential risk of drought. ENSO, with its dual phases of El Niño and La Niña, serves as a reminder of the fragility of the global climate system. The ability to predict and prepare for these events is not just a matter of science, but a critical tool for mitigating their negative impacts on people and the environment. Amid worsening climate change, understanding and responding to ENSO has become more important than ever.